In this video we are going to talk about how the satellite boom is threatening space astronomy in every generation before ours. Humans have looked up at the same sky, the same stars, the same Milky Way, but in 2025, something new has appeared, for the first time in history. The sky is changing faster than astronomers can study it, and experts warn, if we lose our view into the universe, we lose our ability to understand our past and our future. The satellite boom just 15 years ago, in 2010. Fewer than 1,000 active satellites orbited Earth. They were rare, expensive, special. But by 2025, everything changed. Launch costs dropped, rockets became reusable. Space became a business, and suddenly the sky filled up. Today, we have over 10,000 active satellites, and forecasts show we may cross 50,000 by 2030. These megaconstellations promise internet everywhere, from deserts to oceans to remote villages. But they also place thousands of reflective objects in the night sky, all moving at 28,000 kilometers per hour. How satellites damage observations. Telescopes take long exposures, sometimes minutes, sometimes hours. And during that time, satellites sweep across the frame, leaving bright scars. In some observatories, nearly 1 out of every 3 images is now contaminated. In extreme cases, up to 40%. And the Vera Rubin Observatory, one of the most advanced sky survey telescopes ever built, could see 96% of its images affected. This problem is worse during twilight, the exact moment astronomers scan for supernovae, asteroids, and distant galaxies. Even a small reflection is enough to ruin priceless scientific data. Why this is a big problem? It's not just a matter of inconvenience. A single satellite streak can hide the faint signal of a near-Earth asteroid. A faint object, millions of kilometers away, could be lost in the brightness of a satellite trail. We could lose clues about dark matter, which shapes galaxies. We could miss subtle dips in starlight that reveal Earth-like worlds. Cleaning satellite trails takes advanced algorithms, extra computing time, and often reduces the quality of data forever. In astronomy, time is everything, and every streak costs hours, days, or even entire discoveries. How bright are satellites really? Most satellites fall around magnitude 4 to 6, visible in dark skies, and extremely bright in telescope exposures. Even with darkening coatings, like SpaceX's DarkSat and VisirSat, reflections from solar panels remain. The challenge isn't one satellite, but thousands, each reflecting sunlight from a different angle, at a different time, across the entire sky. Why 2025 is the turning point. In just the last 3 years, satellite launches have increased dramatically. More companies, more countries, more demand for orbital space. 2024 alone saw more than 3,000 new satellites, the most ever recorded in a single year. New satellites are larger, brighter, and designed for mass deployment, and combined with Earth's growing light pollution, astronomers now face a sky that is fading, from both above and below. What space agencies are doing about it? SpaceX is testing darker surfaces and deployable sunshades. It reduces brightness, but not enough. The European Space Agency is experimenting with advanced materials that scatter light instead of reflecting it. Global organizations are negotiating brightness limits, similar to pollution standards on Earth. Researchers have suggested special astro-friendly orbits, where satellites avoid key observation zones during peak telescope hours. And new software now predicts satellite paths so telescopes can plan exposures around them. But this adds complexity and limits observing time. Can we save the sky? Astronomers say the sky can be preserved, but the world must act now. The next generation of telescopes will look back to the dawn of the universe, but only if the skies remain dark enough. Without action, the next decade could be the most challenging in astronomy's history. The future of our view of the universe. The night sky belongs to everyone, not just companies, not just governments, but every person on Earth. The question is simple: will we protect our window into the cosmos? Or will we let it vanish behind thousands of glowing machines? Subscribe.